the what was it? We started with the area underneath the curve, right? We did some of those.
Yes.
Now we're going to go over area of areas between two curves. So that's what I was kind of mentioning, how you do the top minus the bottom, right minus the left. That idea is going to be important here, and we'll talk about it again. Area of a region between two curves. Okay. So if if f and g are continuous, on A to B, and G is less than or equal to F for all X in AB, then the area of the region bounded by the graphs of F and G and the vertical lines X equals A and X equals B is the following. So basically, if the top one is the F, that's basically what I'm trying to, so just to put this in plain English, right? This definition here, or this idea, is telling you to integrate the top function minus the bottom function, assuming that we're in dx. If we're in dy, it's going to be the right minus the left, and we're going to go over that in just a moment. So first example, let me show you what, because this is kind of hard to grasp right away, but once you see it, you'll see what I'm talking about. So find the area of the region bounded by the graphs of y equal to x squared plus 2, y equal to negative x equal to 0, x equal to 1. So it helps a lot to graph this. Like a sketch. You can also use Desmos to help you out if you want. It's whatever. I'll try to do a little sketch and then I'll show you in Desmos because it's going to be a lot prettier. So let's say 1 is over here, half is right there, quarters are there. Let's say we have 1, 2, 3 over here. Actually, let's put this on the other side. Let's make that a little prettier. Okay. So let's graph x0, x equal to 1. That's going to be right here, the vertical line. X equals to 1. Then we have the line of x equal to 0 over here, technically, right? The y-axis is x equal to 0. We have a line with slope -1. So at 0, 0, we got a point right there, right? And if you need the chart, let me show you just in case. Like assuming you're doing this by hand, if I plugged in 0 into the parabola, you would get 2, right? If I plug in 0 into this line, you agree that I would get 0. So that's where I got this point. If I plug in 1 into the parabola, I would get -1, right? So the line is doing this kind of thing here. But we don't care about this side. We only care about the 0 to 1 because they bounded that region. Okay.
Okay.
So now let's look at the parabola. We said we have a point here at 0, 2. At 1, you would get 1 squared plus 2, right? 3. So we got a point there. So the parabola closes it off right here. And it keeps on going, right? So picture this zoomed in. And I want to know, what is the area in here? That's what we're trying to do. So these are my sketches of the parabola. I don't really care what happens over here because they bounded it at 0, at 1, below by the line, and above by the parabola. Okay, let me show you a prettier picture with the Desmos. Feel like that'll help. All right, here. So the parabola, the y equals -x. Oh, biscuits. There we go. The line x equal to 0 and x equal to 1. So zoom in here. This section right here that's in here, inside those 4 corners, that is the region they're asking about. They want to know, what is the area inside these 4 little corners? So bounded below by, oh, actually, it goes a little lower than that, doesn't it? This one's not true, it's here. So in this section, I didn't say the y-axis, right? It said y equals -x, y equals x squared plus 2, x equals 0, x equals 1. It did not mention this axis, therefore I have to assume this from these top 2 corners all the way to the bottom, bounded by these 4 graphs. So that's what I tried to graph on paper, but this is a lot prettier, right? Okay, now What is the top function? You can plainly see it, right? What's on top of this little section?
This section.
From this is right. This is where it closes off on top, right? What function is
Yeah.
this?
Square plus two.
The square.
Square plus two.
Yeah, right. So remember we said the top one goes first. So I'm going to integrate. So you write down x squared plus 2 minus, now what's on the bottom? Right? What is the bottom of the region?
Negative x.
So minus the negative x dx. Let me switch back. So the top function minus the bottom function. Do you see how we set this up? Well, we have to have a graph to do it.
Okay.
I don't mind if you use Desmo, that's fine, but you should, I expect everyone to be able to graph a parabola in a basic line, but it's okay if you check your stuff. Any questions on what we just did before we go to the next step?
Okay, let's see. So you have to get the highest and the lowest points, right? Is what you're gonna do on this case.
Yeah, so you look at the section you're closed off, and you look at the top part and the bottom part. That's what goes in here, F and G. That's what this whole long form definition was saying.
Mhm.
Top minus bottom. To keep it really simple, that's what it means. So now the next part, since we're doing dx, that means that we are going to have vertical triangles. Delta x. So basically the idea is you're gonna have a bunch of little rectangles that adds up to area. And that's what the theory behind integrals, right? There's an infinite number of rectangles and the dx is infinitely small. Therefore you get a smooth surface because the smaller they get, the closer they approach a curve. But anyway, since it's in dx, what is the lowest x value and the highest x value? What are the integration, the bounds of integration? I'm going to integrate from where to where?
0 to 1.
Yeah. Does that make sense how we set it up?
Yeah.
Because at this point, we're back to chapter 5, right? 5.1, I think. Find the area. But the setup is the new stuff. So that needs to make sense. Like, can you set this up?
Yes, sir.
Okay. So I'm just gonna simplify a little bit and integrate. So that'll be x cubed over 3 plus x squared over 2 plus 2x from 0 to 1. And then you do the fundamental theorem, right? The for definite integrals at this point, top minus the bottom, 1 minus 0, and you're done. Should be about excuse me, 17 over 6. So we found the area between the graphs. let's do another one. You guys cool on the first one?
Yeah, hold on a second, let me.
Yeah,
Sorry.
no rush.
Okay,
Ready?
yes, sir.
Excuse me. So I'll do the same thing. This time, I'm not gonna, it's gonna be a little less obvious on what the bounds will be. Find the area. Of the region. Bounded by the graphs of f of x equal to 2 minus x squared and g of x equal to x. Okay, so just a quick sketch here. Let's see. My x values, 2 minus x squared and x. Over here, I'll put the values I'm going to choose. Maybe this will be easier to follow. So if I plug in 0, it's usually my go-to number. What would this function be? 2 minus x squared.
Will be
Two.
2.
Yeah, 2, right? And then this one, no big deal, right? Okay, now let's say I plugged in -1. What is this one going to be?
Will be 3.
Mm,
2
Two.
s squared.
Gonna be 1, right? Because you'll
Oh, yes,
square
yes.
this one, no big deal, right? Just plug in some random points, some easy points. Really what I'm actually doing. 1, this one will be the same deal, right? I don't think I need any more, but yeah, whatever. Let's do -2. What's the first one gonna be? It'll be 2 minus 4, right? Anyway,
Uh-huh.
what's up?
No, yes. I got it.
Okay. Now, I need to figure out where these, I just picked random points, right? I need to find out where these two functions intersect. Do you guys remember how to figure that out?
Interesting.
Right. In other words, when are they equal to each other, right? That's the same question. So just find out, when does that happen? when they're equal is when they intersect, right? The same
Mhm.
question. So I'm gonna move everything over here. Is that factor pretty? -2. So it has to be what? +2 -1, right? That means that our solution would be this, right?
Mhm.
Well, so luckily I chose them by accident, right? If I didn't know, I should have done this first and then tested it, but luckily I'm good. So now I have two intersecting points. So I have this guy and this guy. So now I know where the graphs intersect. Yeah, let me try to make some space here. I think I can graph it right here. 0, 1, 2, -1, -2. So the line's no big deal. 0, 0, right? 1, 1. So the line is going to do this, right? The parabola at 0, we have a 2, so it's up here.
And a -1 and 1.
Yeah, -1, 1 is right there. And then the intersecting point is this one, isn't it? 1, 1, 1, -1. Oops, I got confused there. -1, 1 is right there. And the intersecting point was -2, -2. Right here. Okay, so this is the section that I care about. Right, I don't really care what happens after, so whatever. I want to know what's going on in here. Find my area. But you see how I need those intersection points, right? Because without the intersecting points, I don't know what the bounds will be, how far I'm going to make my triangles, like where are they going, my dx triangles or rectangles, sorry. Excuse me. So the lowest point, right, where they intersect, where they close off the region is -2, all the way until the other intersecting point, 1. Does that make sense where the bounds come from?
Mhm.
So now what is on the top of the region?
2 minus x.
Yeah. So 2 minus x squared is on top, minus the bottom. Does that make sense?
Yes.
So you need to be able to graph it, otherwise you can't see what's on top. You can't, and then you have to just solve for intersecting points, otherwise you won't know what the bounds are. The other one, we didn't need the intersection points because they told us where they closed it off, right? They said x equals 0, x equals 1. Here they just said there's two graphs intersecting, right? They said find the area between these two graphs, so they're implying that they're intersecting somewhere. So at this point, we just integrate, right? Okay. Let's simplify this a little bit. Negative x squared minus x plus 2. If we integrate that, we will get negative x cubed over 3 minus x squared over 2 plus 2x from -2 to 1. So just doing our usual power rules, right? Then I'll skip this step. Answer will be 9 halves. Any questions on number 2?
Plus 2, 1.
Okay. So the next one, I'm going to use Desmos just to make it easier and speed up a little bit. Now that you have the concept, I can show you how to use Desmos to make it a little easier. Check your work, or maybe fix up your graph if you mess it up. Find the area of the region bounded by f of x equal to 3x cubed minus x squared minus 10x and g of x equal to negative x squared plus 2x. So they did not tell me any bounds or anything, so we had to graph and then solve for them. But let's use Desmos to make it a little easier, because I need to show you something, why this one's going to be a little harder.
Do we get to use Desmos on the test?
Yeah, I will turn it on. I just gotta make sure it's on before you guys take it. But it should, I will, sure. 3x cubed minus x squared minus 10x. Okay. I try not to be a stickler about graphing, because nowadays it's like you can use so many computer tools, you know, it's whatever. But I do want you to at least know the basics of graphing. All right, so check out these functions. So do you see why this one's going to get kind of weird? Look at, well, let me get the intersections for you. Desmos will give them straight up once you start clicking. See how I have all 3 intersecting points? So that's pretty easy. I don't have to do any algebra because they're right there. But what I want you to see though is from -2 all the way till 0, the blue one's on top, right? And the green one's on bottom. But now look at this guy. From 0 to 2, green's on top. So how would you guys approach this?
Knocking out the blue, the top one.
Can you do two integrals, one for the negative part, one for the positive part?
Yeah, you can just separate it, make two of them. One, the top would be blue, the blue one will be on top from -2 to 0. Green is on top from there to there. So just make F minus G and then G minus F for the next one. Let me show you. So just keep that picture in mind there. So I'm going to integrate and using the intersection points, -2 all the way until 0, the blue one is on top. F is on top.
Is Desmos free to use?
Yeah, it's free. I'm not even logged in or anything. I just go to the website. 3x cubed minus x squared minus 10x is on top, minus the parabola. There we go. So that's one integral you're going to have to do. So then plus the area of the other integral. So after 0 all the way until 2, the parabola is on top. So negative x squared plus 2x minus 3x cubed minus x squared minus 10x dx. Does that idea make sense? Do you see where all the bounds came from? All right, -2 till 0, 0 till 2. Right. I'm always, if I'm doing dx, we're only looking at the x values for it in the bounds of integration, and which means the rectangles are going up and down. If we were to convert to dy, which we will some other later on, we're going to be going horizontal, which means that the right side is the top. But we'll do that later. Okay, so let's simplify these two and see if we can group them a little bit. So there's a minus minus, so that's plus minus 2x. So 3x cubed stays the same. Negative x squared plus an x squared, that'll cancel that guy. Negative 10x minus 2x, so I'm going to have this left over for the first integral. The rest cancel, or combine, I should say. Okay, now plus the other integral, 0 to 2. Negative x squared minus minus, so that x squared is gone. Minus 3x cubed, so that'll be still there. 2x minus minus 10x, that's plus, so that'll be plus 12x. So just do some algebra, distribute the negative, combine like terms. That's all I did. Nothing fancy. You guys still with me, or is that clear? Is that weird?
How'd you get that
Right.
2x on the where your finger is at? That bottom part.
Oh, it should be 12. Sorry.
Yeah, that confused me.
Missed the one there. Because negative 10 minus 2, 12. And
Okay,
if you don't have to do it in your head, where you can always distribute, show all the terms, cancel it, combine, whatever. No, just saving space. You don't have to do that. Is that confusing, or is that okay?
that's good.
Right, well then just this integrate these guys and then start doing our Finding the area. Okay. So this will be 3x to the 4th over 4 minus 12x squared over 2 from -2 to 0. Minus 3x to the 4th over 4 plus 12x squared over 2 from 0 to 2. Which will be 3/4 x to the 4th if you prefer, minus 6x squared from -2, 0, plus well, I guess I could say minus there. Minus 3/4 x to the 4th plus 6x squared from 0 to 2. So plug in 0 first, then minus a -2. See if I can fit this in here. It'll be 0 minus 3/4 times -2 to the 4th minus 6 times -2 squared. So that's the first part. Plus, put brackets on the first integration. So it's a little more clear. So that's the first one here. So now plug in the 2, that will be -3/4 times 2 to the 4th plus 6 times 2 squared minus 0 because of this 0. Okay. -2 to the 4th, that's what, 16, right? 16 times 3/4, that would be what? That 12? 16, 4. So this is a -12. Well, I should say minus is outside, right? This negative. -2 squared is 4. 4 times -6, that is a -24. 2 squared is the same thing I did earlier, except there's a positive, but it's an even power, so who cares? So that should be -12 plus 24. Yeah, man, this is a little annoying. Let's see. Double check my stuff here. 1 second. Getting lost in the weeds. So this is, oh, I see. Yeah. -12 plus 24 minus 12 plus 24 is 24. So I did the bounds this time because there was 2 sets of them. I figure that's probably best we do it. But anyway, you've done this before. This final part. The new part is the setup, and having to keep everything straight because you have two different integrals. You gotta be very careful. You guys okay then? Excuse me.
Can you put the book a little bit down?
Yeah.
Yeah. Right there.
That's pretty much it for area, because we're going to use these ideas. We're going to build on these ideas and go into volume. Let's see here.
And what is this? What is all these calculus 2 preparing us for? Because calculus 1, it prepared us with antiderivatives and all that.
Yeah, so Cal 1 was all about derivatives, which is learning about rates and all the applications that go along with rates, because it's pretty widely used, right? Anything that has change in it, you can apply derivatives to. Cal 2 is all about antiderivative, which is the integration. So finding area, volume, and undoing derivatives becomes like some really important problems. You start seeing like high level physics, like an integral can help you find current of a problem, or calculate the flux of a magnetic field, or find the pressure in a weirdly shaped object. So it starts to come up all over the place. So eventually, right now they're just general problems, but eventually these variables will stand for current or pressure, water flow.
What do we see? What are we gonna see in calculus 3?
Cal 3 is going to be derivatives and antiderivatives, or integrals and derivatives, in 3 dimensions.
What is the math after calculus 3? Is it linear,
It depends what your major is.
mechanical? And I saw actually electrical and mechanical, they have another math class after calculus 3.
The next one is differential equations,
That one, yes.
or also called engineering analysis or engineering mathematics. There's 3 different names depending on what school you go to. It's all the same thing though. It's just differential equations, which is you have a bunch of equations filled with derivatives, and you have to solve them using all your integration techniques. So like in physics, you have like I don't know, let's say you have some physical phenomenon, some rate or some guy jumping off a plane, or once you start throwing in stuff like gravity, friction, all these forces, those forces are all end up being derivatives. So solving for the original function or a place, a position, or a time all turns into integrals. So right now in physics, it's all basic because they're, you know how they always tell you in a vacuum, right? Or in a perfect world or whatever. They always keep saying that in physics. But if we start to allow stuff like friction and you start having, what's it called? A bunch of complex derivatives in your equations,
Yeah,
which requires this.
yeah.
In order to calculate the things like heat collection to dispersion are a couple good examples.
Yeah, I mean, because yeah, you'll see a lot of it in thermal heat transfer. Like pretty much all the physics topics get more complicated because you start talking about 3D and real world stuff, and it's not easy. It's not pretty anymore.
No kidding, I'm working on a personal project and that particular part is kicking me in the rear.
Yeah, it gets complicated, but when you get to differential, they're gonna assume you're a Cal 2 pro, so I would make sure you review all these integral techniques that we're gonna do in chapter 8.
All right.
But I think we'll pause it here. I'll answer some review questions. That's the end for 7.1. Do you have any questions on review?
Yes.
Actually, if this is the end of the lesson, and we're just doing review questions, you mind if I duck out?
Yeah, that's
I
fine.
did a test.
No worries, man. I'll see you Wednesday. Most likely it's gonna be Zoom because I don't think they're gonna clear me in time. They'll probably clear me Thursday, but it's too late by then.
Yeah, I'm still waiting to hear back if my proposed alternative to driving up to
So these cancel. So now 2/3 du will be replacing x to the 1/2 dx. So that's right here, replaced by this. Right. So that will be cosine squared u times 2/3 du. Pull out the 2/3. Okay. So now we're almost done now, right? On the cosine squared though, I'd probably use power reducing or an identity.
Can you use sine square on that?
We could, but I don't think it would help. So what is cosine squared equal to? There's a couple of formulas we can use. I believe there's the power reducing, I think it's this. You remember this formula?
Yeah, identity.
Mhm. So I can integrate this, no problem, right? So that'll be 1 plus cosine 2u over 2 du. So these 2's are gone.
Mhm.
So now I have 1/3 integral of 1 plus cosine 2u. So you can straight up integrate this and we'll be done and then bring back the u. Remember I give you a formula for cosine of some number times u? You can use that or you can do another substitution for the 2u. It's up to you. From experience, I'm just going to use my formula. So that'll be u plus sine of 2u over 2. If you're wondering where that came from, I use the formula I gave you. Or you can use substitution, which is the reason that's here. So I'll just bring everything back to x and we're done. So that'll be x to the 3/2 minus 6 plus sine of 2 times x to the 3/2 minus 6 over 2. So if we want to make it look like what they have, it's going to be this. It looks like number, or what is it? A maybe? Let me see.
Oh, here I got it in number 3 or number C.
Number 3. Let's see here.
Let's see. 1/3 x to the third is 3/3 to seconds plus minus 6 plus 1/6 sine 2. Yeah.
So you go to number 1.
I got, oh, here's on number C or C.
Okay.
Okay.
All right. So number 3 you said, right?
Yes.
Integral of 1 over x ln x to the 6. I think we should let let's see what happens. Let u be ln x to the 6. du will be 1 over x to the 6 times, chain rule says 6x to the 5th dx, right? So
Yes.
du will be 6 over x dx. Because you'll cancel all these with this. So then get rid of that 6 and we're done, right? Du over 6 is 1 over x dx, which is in the problem. That's this piece right here,
Mhm.
right? Okay, so then we're going to have an integral of du over 6 over u. Which is 1/6 integral of du over u, which will be 1/6 ln u plus c. Any steps that are weird? Still with me?
Okay, so I over here in my paper, I have the dx is instead of the 1 up there. So I got dx over
Mhm.
x ln x to the 6. So the dx is over there where the 1 is.
That's fine.
So I just need to move it to the and replace it by 1. See what I mean?
But you had a 6x to the 5th up there too, or no?
Yeah.
No, it doesn't matter. You can
Well-
put the dx on top or over there. It doesn't matter.
Oh, okay.
It's not wrong either way. I just put it to the side for no reason.
Yeah.
Sometimes I
Okay.
put it up top. It's whatever.
Because I got confused because the dx is in top of the fraction and in my example that I have over here.
Yeah, they have it on top, but you can put it on the side if you want to.
Okay, okay. That's why I get confused on that.
Yeah, just think of it as some number, right? Some
Yeah.
number over a 1. I can put it over there, or over here.
Okay.
Who cares, right?
Mhm.
Don't let it bother you. So plug in the u and we're done. So it's ln of x to the 6, which is c.
So, yes.
We can take this test as many as we want, as we
The
can,
review.
the review.
I think at least 3 times, if not more. I need to check. Let me see.
The exam is due tomorrow, right? You set it up until tomorrow.
Yeah, I think it's tomorrow night. It closes. So it started before 10 p.m. the latest. I put 10 attempts. That way, keep messing with it.
On the number 9, you have 2 to the e, 5 to the x, dx. You have to just the u in that case is just 5x. Is that right?
Let me see.
It's number 9.
Number 9. This one, yeah, you just do a substitution for the 5x.
Is that that's the u, right?
Yeah, that'll be you. Do you want to do it or you see it?
Yes. Can you do that for me?
Okay, number 9. The integral of 2 e to the 5x dx.
Can you move the book a little bit?
Yeah.
Yes. Okay. Mhm.
So let u equal 5x, du equal 5 dx, right?
Mhm.
There is no 5, we actually have a 2. So there's 2 ways you can think about this. You can pull out the 2 and just pretend it doesn't exist and get rid of the 5. Or we can try to make it look like 2 dx, right? So how do I change this into a 2? What do I multiply 5 by to get a 2? What, it's a fraction, so a hint.
To get a
Because I need a 2 over here, right?
yes.
Well, if you can't see it, we could do it in steps. But I know for sure there is no 5, so let's get rid of the 5. Right? Maybe this makes more sense.
Mhm.
Now I need a 2 there, so multiply by 2. Ah, crap. So now this is there. It'll be replaced by this. So this will become e to the u 2/5 du.
Mhm.
That makes sense?
Yes.
So pull out the 2/5 because this does not do anything for us. And then we get 2/5 e to the u plus c, which is 2/5 e to the 5x plus c.
Okay,
The steps make sense, or
yes, yes, yes. Yeah, because I don't know, I didn't know what to do with the E. So the E is not nothing. I mean, we don't, I mean, the only U is 5x, and then the DU is the derivative of that.
Mhm.
Okay, okay.
right? It's always going to be derivative.
All right. All right, let's see.
Oh, could I get help with 5?
5. Sure.
Oh, yeah. that was-
I'm going to use x, by the way. So that u equal ex minus 7, du equals ex dx. Right? There's my ex and dx. So this will give me integral of cotangent u du. Integral of cotangent. What is integral of cotangent?
Tangent is the second.
It's going to be one of the ln's. It's a ln. I forgot actually. ln.
The tangent.
Let me double check. It's from the formula table. It's ln sine plus c. You can derive this by doing another substitution, but if you use a table, that's fine too. Guess I should show you how to do it. Now that I think about it. This chapter is trying to show you how to create them. So you guys agree that cotangent is cosine u over sine u, right? So let w equal sine u. dw will be cosine, right?
Mhm.
du. So that gives me dw over u, integral being ln, oops, that's the ugliest w ever written, right?
Mhm.
Replace w, which is actually sine u. Replace u, which is actually sine of ex minus 7. That's what you're supposed to do. I was just being lazy at first. I'm sorry about that.
ln. Okay. Okay, let's see.
Any question on this one?
No, I had
No,
another.
sir. No,
Uh, is there a way we can get all the formulas like in like one paper, like in the modules or something?
I think I might, let me see. For that chapter, all you really need is an integral formula chart. Let me find one for you. Oh, here we go. This is a good one. Can you guys see that? All you really need is the integration properties. Let me see if I can turn that into a PDF for you because that looks kind of shitty. One second. It's a little better, but not the best. Yeah, all you really need is the ones that say common integrals and the integration properties. If you're going to write them on a sheet yourself, that's fine too. But they also have these use integration by substitution on the right-hand lower right corner. All the other stuff we haven't talked about yet, so I wouldn't worry about it. Fundamental theorem is right there. We did talk about that one. So ex dx over 1 minus e to the 2x. So basically, well, we have to set it up first. You need to be able to see that this is a trig subtype or trig inverse trig integral. Sorry. See how you can rewrite this, right?
okay.
So make it more obvious to you. So now I have du over the square root of 1 squared minus u squared. So look, open that sheet I just sent you. It looks like on the common integrals, the last one on the right, it's a squared minus u squared, right? This will be sine or arc sine if you prefer, sine inverse, whatever. Arc sine of u over a plus c, which is the same as e to the x over 1. And if you prefer, you can use the other notation, sine inverse of ex plus c. It's the same thing.
Okay. Well, can you do number 8 by any
Yeah,
chance?
sure, man. That's what I'm here for, right? Let's see. This one looks like,
It's like the one we were talking today, right? The limit, I mean, the bounds.
yeah, it looks like a bounded type. Okay, it looks like I should let the bottom be U. Because it's on the bottom and it's a higher power, so those are 2 hints why I chose it. I do not have a 3x squared plus 3 on top, but we can plug out or factor out 3. Oh, we just did 7. Wow, what's that? Divide the 3 out. And we're good, right? That's on top.
Mhm.
So this will be D over 3, and the bottom is U, right?
Yes.
Sorry, good. So integrate that guy and you'll get 1/3 ln U from 2 to 3, but these bounds are for X, so I need to bring back the X in order to use them. Otherwise, I'd have to change the bounds, which I don't like to do. I don't like to do more work than I have to. Make this a little prettier. Okay. So I'll just plug it in and we're good, right?
Yes.
So ln of 3 cubed plus 3 times 3 minus 1/3 ln of
Cube.
2 cubed minus plus 3 times 2. So that's what, 27 plus 9?
27,
What is that going to be?
6,
36. 8 plus 6.
14.
Factor out the third. Now, if you're dividing if you're subtracting 2 logarithms, you divide, right? Remember?
Mhm.
So you're going to get 1/3 ln of 36 over 14. Which reduces to what?
36 over 14. You said 36 over 14? Yeah.
18 sevenths, is that right?
See. Eighteen sevenths.
And that's it.
Okay.
Any question on that one?
No, now it looks simple.
Can you scroll up the,
Yep. Now it looks simple.
All right. Let's see here. Someone had a question about number 6. You guys cool on 8?
Yes.
All right, integral of dx over x times 9x squared minus 7. This looks like another trig type. I believe this is a secant problem from the formula sheet. So let's rewrite the problem first as x times square root of 3x squared minus square root 7 squared. Right?
that X on, with the square root at the bottom?
This 3x both squared, square root 7 squared.
Yeah, but that X, outside the square root.
Yeah, it's just times the root.
Okay, it's times, okay, it's not.
Yeah, it's not it's not the actual root. It looks like you're right. Okay, so it looks like secant. Look on your sheet. Where is it? Did they not put secant? in here? That's weird. Yeah, I would add that to the sheet. They didn't put the secant. Let me double check. I believe it's secant of u minus a or u over a or something. Let me double check though. Yeah, here it is. It's going to be 1 over 1 over a, which is, this is my a and my u. 1 over square root 7. Secant inverse or arc secant if you prefer. And on the top, you have the absolute value of the u, which is 3x over the a, square root 7 plus c. So we really didn't do a sub, just did a straight up formula. But you could have subbed the 3x, I guess, but that's not necessary. Looks like either A or D. They went one step further. They rationalized the square root. You see that? Because we don't like square roots on the bottom. That's the only difference. I think it should be D because the formula has absolute value on the variable. Oh, no. Yeah, it is D because it's secant. The top one is sine. My bad. The only right answer is D. I thought they were both secant. I'm like, shoot, that looks almost the same. Anyway, I guess we'll stop here. It's almost time to go. I'll have time for another one.
All right. Good job, everyone. Thank you, Professor.
Yeah, no worries. I'll see you guys Wednesday on Zoom. I doubt they'll let me go. Yeah,
Okay.
if
So
Monday, I'm-
one last question on, so every week we have to go and get tested, right? Even that we are on Zoom.
yeah,
Is that
yeah,
right?
that's right.
Okay.
No, you have to. It's not up to me, but
Well, rules are rules and everything's for our protection.
yeah, I know. I wish things were simpler.
Well, you know, we are surviving this. Everybody's surviving this.
Yeah, I know. It's been almost 2 years now. It's getting close to 2 years.
Yeah, like when it started, I was in my spring in college algebra, I think. Yeah, 2 years already. Yeah.
Crazy.
Yep, it is crazy. All right, so I'll see you guys on Wednesday.
See you guys Wednesday. Take
All
care.
right, thank you.
Professor, quick
Good night, guys.
question.
Sure, man. What's up?
No, on this number 6, so
Mhm.
the X and the 3X, do those have to equal? Because that's how looks like that's how the formula is set up, but
Does what has to equal? I'm sorry.
the X and 3X, the two U's or X's in the formula,
Hmm.
do those have to equal? Because that's what I was trying to do. I was trying to make that 3X, the X in the front be 3X, so they were both the same. Because I feel like that's the way that's set up.
Yeah, I rewrote the 9x squared as 3x squared.
Okay.
So because the formula requires something squared, let me show you the formula it's in your notes, but here's
Yeah, I have it in front of me. So it's
yeah.
U and then square root or X square root X squared minus A squared.
Yeah, exactly. So this is like the X term right here, the 3x or
Okay, but but 3X isn't X. I guess that's what I was getting confused on.
yeah, so this inside part is the quote unquote X.
And then the X in front of the square root wouldn't have to be a 3X. You wouldn't have to have a 3 in the front there. So they're both the same.
Oh, you're right. That's a good point. If I were to, yeah, because there is no 3 there. Let me look at the answer again.
I think I got this. Let me look it up. Oh, it took me forever to get this one. I was just trying to.
Yeah, there is no. There's an X there, but not. there.
Okay, so yeah, I substituted, and then it ends up
Yeah.
canceling out.
Yeah, that's what I was thinking. If
Yeah.
you were to sub it, I guess I cheated. Yeah, so I forced the formula, but yeah, technically they should be the same before you apply the formula. I just applied it anyway, which is technically not correct. Yeah, we should do a U sub to deal with this guy. You could technically do this. I mean, here's a legit way to cheat, right? See what I mean? You could do it this way if you want. So now it matches up.
Yep.
So you would integrate. And you'd think it'd turn out just fine. I can pull this 3 out over here, integrate this nonsense. Or do the U sub here, it would still work out. The only thing is if I do it this way, I feel like there should be a 3 in front because these will all integrate, but that 3 is not supposed to be there, right? But there is no 3 on the answer. You said yours came up, you said?
Yeah, because let me see what I did. I let u equal 3x. So then du equaled 3. And then I added, let's see what I did. Basically added a 3 on one side and a 1/3 on the other, I guess, or a 3/1 and a 1/3, I guess. to
Did your
kinda-
final answer have a 3 in front?
No, because it ended up canceling each other out the way I did it. I'm not
Hmm.
sure if it was the right way, but
No, I think your way is the better way.
but
Because
yeah, so
here I'm skipping a step and not doing the sub. I mean, it worked out, but I don't like that. There's
yeah, I
no
basically
3
did what
there.
you did. I added a 3 on the top and the bottom.
Hmm.
And then I brought out the 3 that was on the top and left the 3 on the bottom. And then that 3x ends up becoming no, that doesn't work either. Shit. What am I doing? I'm gonna have to do this one again.
Let's see here. Yeah, I think once you introduce that 3, you then do the sub and it works out. Yeah, I think that'd be the extra step that I was missing. It turns out to be the same. So right here we end
Oh,
up
yeah, there we
with
go. Yeah.
arc sine of u over square root 7. Oops, sorry, arc secant inverse.
Yeah, add the 3 first. Yep.
So yeah, so this was
Then it becomes-
legit.
then
Then
first
do the u
becomes-
sub. Then you get secant inverse 1 over square root 7. Keep smearing it. Okay, so that's gonna be 1 over square root 7 secant inverse of absolute value of u over square root 7 plus c. And then we get our what u used to be. So that's where the 3x comes from, square root 7 plus c. And then if you rationalize, you would get 7 over square root 7 over 7 secant inverse. And then 7 over square root 7, 3x plus c. You can put the whole number inside the absolute value if you want to, but who cares? Doesn't matter. But yeah, I missed a step there. Thanks for mentioning it. Forgot about it.
Yep. Yeah. Yeah, that's basically how I did it. Just
Cool.
Not as neat as yours.
Appreciate that. All right, guys, it's time to, I need to pack up my stuff and start getting ready for bed. So I'll see you guys on Wednesday, okay?
Thank you,
Okay,
sir.
thank you.
Appreciate it.
Take care.
Go ahead.